Hello everyone, this is Sharon O'Hare and Kyle Feller with the coding assignment number 4 with the video. We're going to jump right into stuff with problem 1. It says write a function Bayes that computes the probability of B given A, provided the values for PB, PA given B, P of B naught, and P of A given B naught. So we have those 4 inputs and we're supposed to output P of B given A. So we have this math statement, and then this this function has 4 inputs: P of B, P of A given B, P of B naught, and P of A given B naught. And P of A given B times P of B, that quantity divided by P of A given B times P of B, plus the quantity P of A given B naught times B naught is in the denominator. So once this runs, it will set this whole string of math statements to the PB given A, which is our output, and then it will return PB given A. And then once we show that that works, so Bayes' theorem of these are the 4 inputs, this is the output, and our expected output is correct. And then when we run this one with a different set of numbers, our output is also correct. And then I'll turn it over to Kyle for the next function. Thanks.
Hi, this is Kyle, and I'm showing you the expected value function. So what it does, it's taking the list of outcomes and a list of probabilities. So it's going to run an if function and see if the sum is equal to 1. By doing so, the for loop within that, it's going to run through every element, which then EV plus or equals outcomes times probability to see if it will equal 1. If not, it will return a false statement. So as shown for this example here, when running, it will come out to 3.5, since the sum of these are equal to 1. And it will do the same for these two as well. So here, I'll show you. Yet for the last one, it will not, because it's not equal to 1, so it will return a false, as shown right here.
Alright, so this generated grid function takes in 2 inputs. It has prob, which is the probability that a 1 will show up, and square number, which is the number of squares in each row and column. Since it is a square, it will have the same number of row and column. So basically this function generates a grid as a list, and then each item in the list will either be a 0 or a 1 based on a random probability. That's what this if statement does down here. It takes a random decimal value, and if it is less than or equal to the probability, input a 1 in that specific square. And then obviously the return statement, it will return the entire grid list.
Back again with the draw barrier function. So what the draw barrier function will do is it will draw a barrier when a cell number is equal to 1. So what it's doing is a for loop within a for loop. So it will take row, it will go through row once, and then it will go all the way through column. And it will see if grid is equal to 1, which the cell is equal to 1, it will draw a barrier there. So that's what the pygame.draw.rect will do. It will actually draw the physical barrier there of the cell.
Alright, it's me again. So we have this method called getCell. It takes in the grid size, takes also in the number of cells in each row and column. It also takes in the current X and Y position of you, the player. So this function starts out by doing a little calculation to find the size of each square. It takes grid size and divides it by the number of cells. Then it sets row and column to the according Y and X position divided by the square size. So for row, it's Y position divided by square size set to an integer, and for column, it's X position of the player divided by square size parsed to an integer. It then returns both
Back again with the corner points function. So what this is doing, it's trying to find the coordinates of each corner point of a cell. So what this will do is it will take the M, which is the length and width of the game window, the cell number, which is the number of cells in each row and column, the X position of the player, and the Y position of the player. So what it's going to do is square size is equal to the length and width divided by the cell number, which is also going to run through the top left, top right, bottom left, and bottom right, and then it will return it later on to show where the exact coordinate points of the player is, which is what it's trying to return is a 4-tuple.
Alright, so for our final function, it's defined as move, takes in the current position of the player as x and y components, takes in the distance the player moves in each key event, takes in the grid as a list, and the grid size and square size. It has 4 key events for each appropriate key press, left, right, up, and down, and then within those key event checks, it has various additional checks for open space and for wall barriers. So the first line of each of my if checks is a check for the wall barrier. So for this left wall, it is if x position is greater than 0, and which we'll figure out what the rest of it is later. So that checks for the x position of the player being greater than 0, which is grid size, which if it's less than 0, it means the player is outside of the boundaries, which that can't happen in a video game. So now to what the AND means. So if that equates to true, and grid int y position divided by square size, and x position minus 1 divided by square size, if that is equivalent to 0, meaning if there is open space to the left of the top left corner, then if that equates to true, and the above statement equates to true, and the third statement equates to true, which is the same thing just for the bottom left corner, if all 3 of those equate to true, then the player can move to the left. The same thing for the right key event. Checks for the right edge of the player box, checks for against grid size. Then it also checks for the top right corner if there's open space next to the top right corner, and if there's open space next to the bottom right corner for the right key event. So it's checking both sides of the right side of the player cube. For the up key event, it checks the top right and top left corners respectively, and for the bottom, or for the down key press, it checks the bottom right corner and bottom left corner of the player box. So if we run this, then we can see that you cannot move into a box anywhere if there is one collision. If there is one collision from that side. Also, if you move, I'm moving all the way around this box. I cannot move into the box at all. And then I cannot move to these barriers either. Yep, and it's the same for the lower barriers. Alright, so this is Sean O'Hare and Kyle Feller signing off. And thank you and goodbye.